Welcome class. Today we're going to be talking about section 4.5 from the book, Graphs of Sine and Cosine. Now the key thing today is the question, the essential question, how do periodic functions work in nature? So this is an essential question. Now, before we can even get to the essential question, we kind of have to understand the basics of our periodic functions: sine, cosine, tangent, cotangent, secant, cosecant. But clearly we're starting today on sine and cosine. Now, before we begin, we do have biblical integration today, a concept from this that I want us to look at. But we will spend time in the second video talking about it, okay? So this first video will not cover it, but pay close attention because the second video will indeed cover it. Okay. Now, one cycle of sine and cosine curve. Now, on your notes, there are some definitions and stuff. You can come and go fill in them in. But one cycle, clearly you can see that sine and cosine are periodic. That is, that they have a set period where they will repeat the same thing. They cycle through the same idea. That's why one cycle is from 0 to 2 pi. It goes, you notice that the pattern, we go up and then back down, and we land on the same point. Now notice we have maximums, minimums, and x and y intercepts, okay? I want you to clearly look at those because you want to notice we have a clear range from -1 to 1. We have a clear domain for our period, that is 0 to 2 pi. And for our function, sine and cosine of x, we notice that it goes on forever. Now this is our sine of x up here, and we see that it starts at 0, goes up and back down. Cosine starts at 1 and goes down. Okay, that's going to be important for mapping some of the things we need to do. Okay, key points: intercepts, x-intercepts, y-intercepts, maximum and minimum. Now, x-intercept for sine is going to follow the pattern 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, or negative. So 0, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So it follows the same pattern. Now for cosine, our x-intercepts will be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. So you see the pattern, it's going to be odd on top. Also negative. So negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on. The y-intercept, there's only going to be one for each. 0, 0 for sine of x, and 0, 1 for cosine of x. The maximum point is going to also follow our pattern. So for sine, it's going to be pi over 2, 5 pi over 2, 9 pi over 2, or pi over 2, negative 3 pi over 2, negative 7 pi over 2, and so on. Now notice that it follows a 2 pi function because it will repeat the same maximum and minimum every single cycle. So its minimum for sine is 3 pi over 2, 7 pi over 2, 11 pi over 2, or 3 pi over 2, negative pi over 2, negative 5 pi over 2, negative 9 pi over 2. For cosine, the maximum is going to be 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, it's evens. For its odd, it's going to be, for negative, it's going to be 0, negative 2 pi, negative 4 pi, negative 6 pi, negative 8 pi. Its minimums are going to be pi, 3 pi, 5 pi, 7 pi, 9 pi. Similarly, its minimums on the negative side are going to be negative pi, negative 3 pi, negative 5 pi, and negative 7 pi. So it follows odds. So cosine is actually going to be a rather consistent function. Okay, now graphing with those. you would plot those key points, the x-intercepts, the maximum and minimum, and then you will draw the curve between those points. Notice it's a smooth curve for each of these, okay? So you draw the maximum, minimum, and intercepts, and then draw the line between. Okay, this is the key equations for sine and cosine. We will dive into it. Y equals d plus a sine bx minus c. Y equals d plus a cosine bx minus c. You can always pause this video if you would like to look more into it. Okay, the amplitude is defined as of y equals a sine of x and y equals a cosine of x represents half the distance between the maximum and minimum. So think basically the amplitude is half of your range. Given by amplitude equals the absolute value of a. Let b be a positive real number. The period of y equals a sine of bx and y equals a cosine of bx is given by the period equals 2 pi divided by b. Why is it 2 pi? 2 pi is the average one cycle of sine of x and cosine of x. B is changing that. It's our horizontal stretch or shrink. If b is smaller or fraction, we will stretch. If b is a larger number than 1, like 2, it will be a shrink, horizontal shrink, okay? Think of it like an accordion. Okay, accordion stretches and shrinks. And the smaller b is, or the fraction it is, like 1 over 4 or 1 over 6, the period is going to stretch. Okay, one cycle and phase shift. Now, the interval for one cycle is c divided by b is less than or equal to x is less than or equal to c over b plus 2 pi over b. I will explain these and how to find them. You just need to record them, okay? So in the next video, I will explain how to use these and what you need to do, okay? Phase shift is c over b. So phase shift, think of phase shift as the horizontal translation, okay? The interval for one cycle tells us when we're graphing it on a coordinate plane, what do we graph? We graph one cycle, we graph the interval. Okay, this is the summary. So the summary, the graphs A, sine bx minus c, and y equals a cosine bx minus c have the following characteristics. Assume b is greater than 0, amplitude equals absolute value of a, period equals 2 pi divided by b. The left and right endpoints of one cycle interval can be determined by solving the equation bx minus c equals 0 and bx minus c equals 2 pi. Okay, so you do need to track what your bx minus c equals, okay? That would be the easiest way of solving for our endpoints of one cycle. Okay, remember, did you see any d here? Remember back here, this is our graph. This d is our y translation. Our vertical translation is d. Our horizontal translation is going to be c and b. Okay? Okay, that is it for now. We are going to do in the next video some practice problems. Okay? Okay, thank you guys so much for joining this first video. Second video will start